In this session, I will be explaining about the logarithmic problems. Let us discuss first of all what is logarithm. It is simply represented as log, that is logarithm, or you can simply put log. Log 2 is given by the value 0.3010. You please take down the values. Log 20 is given by 1.3010. Log 200 is equal to 2.3010. Log 2000 is equal to 3.3010. So from these values you are able to observe one important thing. What about this 0, 1, 2, 3? For example, when you have a single digit in the logarithm, you put 0. When there are 2 digits, you put 1. When there are 3 digits, you put 2. When there are 4 digits, we write 3. But being 2, we write the decimals as 0.3010 in all these cases. Now, so let me start from here. This 2000 can be written as, that is log 2000 can be written as 2 into 10 power 3. Are you able to follow? In fact, we write this 10th power as the number here. So that is 3 point. Are you able to follow? Similarly, log of 200, that can be represented as 2 into 10 squared, and we write this 2 as 2 here, 10th power of 2. And what about this one? Log of 2 into 10 power 1, we write this 1 as mantissa of log 20, that is 1.3010. And what about 2? That can be written as log, that is 2 into 1, that is nothing but 10 power 0. So we write this 0 as the logarithmic value of log 2, that is 0.3010. Are you able to understand? So from this, there is some hint here. That is, this log 2 is actually logarithm of 2 to the base 10. Are you able to follow? Logarithm of 2 to the base 10. It should be read like this. Okay? And there are some logarithm based on exponential, and these are called natural logarithm. Take down natural logarithm. Here, for example, that is logarithm, natural log 2 means log 2 to the base e. Are you able to follow? So such type of logarithms are called natural logarithm. And this is not equal to logarithm to the base 10, that is different. These are all called natural logarithms. For instance, when I put, that is you know something about the exponent. Okay, so this is represented as exponential term e power x. Are you able to follow? So e power x is equal to, let me say, y. When I introduce logarithm on both sides, introduce log on both sides, now it becomes natural log e to the base x is equal to natural log, that is y. Are you able to follow this? Okay. And the natural log of exponential term, there is a rule called power rule. So you can bring this x to the coefficient. So it becomes x into natural log of exponential, that is equal to log of y. Now this natural log, logarithm, natural logarithm and the exponent, these are, that is, they are inverse to each other. So that is why it becomes 1. So natural log of e is always 1. In that case, x is equal to natural log y. Now, in fact, this e power x can be written in the form of x is equal to log y. Are you able to follow? When you write like this is called exponent form. The same equation can be written as logarithmic form as x is equal to log y. Okay, so do you understand this? Similarly, we can take logarithm to the base 10 also. Let me explain about this. For example, let us consider logarithm. Log, let me say 100. Log 100 to the base 10. Log 100 to the base 10 is given as 2. What do you mean by this? For example, log 10 square to the base 10 is equal to, okay, this 2 can be brought here according to the power rule. So 2 log 10 to the base 10. There is one more logarithmic rule, that is, when you have, that is, log a to the base a, when you have both the similar terms, it becomes 1. Likewise, log 10 to the base 10 is equal to 1. Log e to the base e is equal to 1. Do you understand? And that is why I put natural log e is equal to 1. Do you understand? In the previous case, I was explaining about this natural log, that becomes 1. ln e is equal to 1. It means I can put logarithmic what? Exponential to the base e. So it should be given like this. Do you understand? And as per that, now this becomes 1. Therefore, this is 2. Now we have proved this. Are you able to follow? So log 100 to the base 10 can be written as what? That is log, let us simply put 100, okay, to the base 10. Okay, so this is nothing but 2, means this represents 10 squared is equal to 100. So what we write here is, we write the power term as the logarithmic value. Okay, so I'll try to change this. This can be, this is the power term. Now this can be converted into logarithmic term. That is log, what you are supposed to do, put this 100 here and take this 10 here as base. So the value is 2. Are you able to follow? I hope now you should be able to understand how to convert the power term into the log to the base 10 or the exponent term to the logarithmic form. Okay, let us do some exercise so that you will be able to understand in a better manner. My dear students, in this tutorial I will be explaining about how to find out the log values very easily. See, look at this flashcard. Here I have written 2000, that is the question, 2000. We have to find out the logarithm for 2000. Log 2000 means that is there are 4 digits. So 1, 2, 3, 4 means a 3 point, and we had to search for 20 in 0. So 20 in 0. What is that? 30, 10. So what you are supposed to do? 3.3010. So that is the log value of 2000. Okay. So let me explain further. This 2000 is represented as scientific notation 2.0 into 10 cube, and that 3 is given here. So 3 point, and for 20 you have to find out in 0, so 3010, so 3.3010. Okay, right. And similarly 3423. So what is the log value of 3423? That is, there are 3 digits, so you can have 3.4 digits. You can reduce 1 digit, so 3 point, and check for 34 in 2 and 3. So 34 to 5340 and go there in 3, 4. So the mean difference is 4. So this is 34 means 5340 and 4. So 5344. So 3.5344. So this is 3.5344. Are you able to find out? So likewise, what is the logarithm value of 495? There are 3 digits, so you can put 2 point and then find out the logarithm for 49 in 5. So 49 is here. Okay. 49 in 5. So 49 in 5. So 49 in 5 means 6946. So 6946, and there are 2 digits. 3 digits. So you have to reduce 1. So 2 points. So 2.6946. Are you able to understand this? And what about 564? 5.64. You have to take only the value and not the decimal. So 5. It means 56.4. So 5 means only 1 digit. So you have to put 0 point and 56.4. So check in 56.4. So take the log in 56. So 56.4, 75.13. So 75.13 means 56.4, 75.13, 0.53, 70, 56.4, 56.4, 75.13. So 75.13, 2 point. Are you able to follow? And similarly, if it is a 0.006, 0.0063 means there are 3 digits here. Okay. And that is 4 digits, but you had to consider only 63. But after decimal point, you got 4 digit. So what you are supposed to do, take the scientific notation, which is 6.3 into 10 power minus 3. Is it not? So 6.3 into 10 power minus 3. And that minus 3 is written as a 3 bar. Are you able to follow? Otherwise, you can simply remember there are 2 zeros after decimal. So you can increase 1 digit and put 3 bar. So 3 bar. If there are 2 zeros means 3 bar. 1 0 means, not here because you have got some number here. So you have to include 6.0. In this case, there is no number here. So you have to include only 63, and for 2 zeros you can increase 1 digit, so 3 bar. So 3 bar, and find out the 63 log. Log 63 is, you can check log 63, 7993. So 7993. So 2 zeros after decimal means, and that should be 0 also in this case. So 0.00. So ignore this 0, and there are 2 zeros after decimal point. So 2 zeros means 3 bar. So 3 bar 0.7993. Okay. So as I already explained, this is nothing but the 10th power of scientific notation, that is represented as bar. So 6.3 into 10 power minus 3, which is nothing but 3 bar. So 0.67993. Similarly, 6.022 into 10 power 23 means 23 point. Find out 60 and 2 main difference. 60 to 7796 and again to 1. So 7797. So 7797. Are you able to follow? So this is the way you have to find out. Okay. So you can have a practice of this code also. Let us further practice this one. This is 1.67 into 10 power minus 7. So 1.67 into 10 power minus 7 means 27 bar, and find out the logarithm in 16 in the 7th column. Okay. So 16 in the 7th column. 16 in the 7th column is 2227. So 2227. Are you able to find out? This is 2227. Okay. So 27 bar 0.2227. Similarly, 1.6 into 10 power minus 19 means 19 bar, and check for 1.6, that is 16. 2041. So 2041. Okay. And for 3.414, 0.34 you have to check in 1 and 4 mean difference. So 34 is here. 34 in 1. 34 in 1 means 5328. Okay, 5328. And here you have to check in 4. So 5. It means 5333. 5333. So since it is a 3 point, that is, you have to reduce one digit. So 1 digit minus 1, 0. So you can put 0 point. Similarly here, there is 0, and after decimal 2 zeros. So 3 bar. So 3 bar. Otherwise, you can make the scientific notation. Now 71. 71, what is the value of logarithm in 71? 71 is 8513. 8513. Are you able to follow? So 8513 I put. Okay. Can you follow this? Right. And similarly, you should be able to find out the anti-log also. Now let us check 0.3010. What could be the anti-log? 3010 means 0.30. So go here 0.30 and 1 and 0. It means 1995. As I already mentioned, you have to take one decimal. So you can write 1.995. So for anti-log, you can write anti-log of 0.3010 means that is 2.30. Where is 30? 30 and 301. So 301 means 2000. 2000. So 200. You have to take the value 2000 and plus 0 main difference. So 2000 means take one digit 2.00 into 10 power. Whatever the value you have here should be written as 10th power. We know already 10 power 0 is equal to 1. So 2.00 into 1, that is 2.000. That's all. Okay. And find out 1 bar 699069. So let us check the anti-log of 69. 9 means here. So 5000. So it means 5000. As I already mentioned, that is anti-log of 1 bar 990 means you have got 5000. Now what you are supposed to do, take 5 point single decimal into 10 power and you write power minus 1. Whatever you have here can be written here. So 5.0 means 0.5. Okay. So the value is 0.5.
Got it? So likewise, we have to proceed these values. Okay, try these values. Try to find out the antilog of all these values, right?
Now let us try to solve this problem by using logarithm. First of all, let us try to understand what logarithm is. There is another term called anti-logarithm. So this is the logarithm table where you can find, that is, it starts from 1 0, that is 10, and vertically it goes like this. Okay, so in this page you have got 54 and here up to 99. Okay, up to 99 it comes. Now suppose if you want to find out the value of logarithm of, here it is given 1.014. So how to find out the logarithmic value of 1.0141? You have to consider 10, the first two digits. So you have got 10. Now the next digit is 4. So go to the fourth column. What is given here? 0170. And again it is 1. So you have to take the mean difference, and this is the mean difference. 4 is the mean difference. So what you can do, you can take like this. Let me write the logarithm of 1.041. Log 1.041. So its value is, now what you are supposed to do is, before the decimal, if you have got only one single digit, you can put 0. If it has two digits, you can put 1. If it has three digits, you can put 2. So now you have got only one digit, that is 1 point before decimal, 1 point. So only one digit. So you can put 0, point, and then 10 4. Now let us look at the value 10 4. So here it is 10 and come here, that is fourth column, 0 1 7 0. So you can make a note of it, 0 1 7 0. And then now you have got another, 1. So 4 10 4, 1 is the mean difference. The mean difference should be added here, 4. That should be added in the last digit. So you can write down like this, 4. So this is the 0.01704. This is the value of log 1.041. Do you understand? Similarly, you have 2.342. So for 2.342, you can try with, that is, here you have 2.342. So 2.342, you have got the value, that is, you have to consider 2 point means 0 point because single digit. So let us write down log log 2.342. So what is that? For 23, you have to check 23. Take 23. So this is 23 and 4 2. So 23 4. Fourth one. So this is 3692. Is it not? So you can note down this value as 0.3692, and then the mean difference is 2. So for this 23 and 4, then mean difference is 2. So 23 4 mean difference 2 means 4. So you can add 4 here in the last digit. Therefore it is 69630. So this is the log 2.342 value. Okay, please note down. And similarly, you had to find out log of 3.1, right? 3.1. So log 3.1 is equal to, put 0 point because single digit. So 0 point, then 31, and after that there is no digit here, so we can put 31 0. So 31 0 is how much? 4914. So you can write down 4914. And what about log 4.062? Log 4.062 is equal to 0 point. Now 4062, you have to check 40. So where is 40? 40 is here, is it not? Can you see? 40 and 62. 6, that is in the sixth column, this one is there. So this is 6085. Okay, 6085. So you can write down 6085. Now what is the mean difference? 2. So for 2, the mean difference is also 2. So you can make a point 2. Now this is 0.6087. So this is the value of log of 4.062. So we have found out the log of all these values. Now what you are supposed to do? These two are denominator, is it not? And these two are numerator, and these two are denominator, or the fraction given problem. Okay, so let us consider there is a rule called product rule, okay, in logarithm. What is product rule? Take down product rule. Product rule is nothing but log of a into b is equal to log of a plus b, that is log a plus log b. Similarly, quotient rule. Quotient rule is log of a divided by b is equal to log a minus log b. Do you understand? So based on that we have to proceed. Okay. Now the numerator where we have got 1.041, 2.342. So let us rewrite in a neat manner. So let us isolate all these powers separately. So 1.041, 1.041, and then 2.342 into 2.342 divided by, what about this one, 3.1. So 3.1 into, what is this, 4.062. So 4.062 into, now let us have the 10th terms, 10 power terms, 10 squared into 10 power minus 3, 10 squared into 10 power minus 3 divided by, here 10 power minus 1 into 10 cube. So 10 power minus 1 into 10 cube. Are you able to follow? Now we get, let us solve this alone. This can be done manually. So 10 squared into 10 power minus 3, we know what is that, 10 power minus 1, 10 power minus 1, and this one 10 power, because we use the formula a power m into a power n, is it not? A power m into a power n, that is equal to a power m plus n. In that case 10 squared is there into 10 power minus 3, it means 10 power 2 plus of minus 3, therefore 10 power minus 1. Do you understand? That is why I written here. And what about 10 power denominator, 10 power minus 1 into 10 power 3. So a plus b, 10 power a power m plus n. So here 10 power 3 minus 1, that is 2. So you can put 2, and finally it becomes what? 10 power minus 1, and this 10 power minus 2 can be taken in the numerator as 10 power minus 2. So totally 10 power minus 3. So the answer given here should be multiplied by 10 power minus 3. And before that we should try this using logarithm. Okay. So we have got already these log values. What are those? That is, now we have got the numerator. Okay. Let us consider the numerator. What is that? First we have got 1.041, for which the value is 0.0174. Another value is log 2.342, so 0.3696. Now this is multiplication, we can apply the logarithmic rule, we should add product rule. So 6 plus 4, 10 balance 1, and then 10, 17 balance 1, 7, 1, 8, and then 3. So 0.3870. Do you understand? Now you can keep it as such. And what about the denominator? The values of denominators are 0.4914 and here 0.6087. Now let us add this. So 4 plus 7, 11, balance 1, 9 plus 1, 10 balance 1, again 10 balance 1, 7, so 1.1001. Now this is the denominator. So here it is the quotient, is it not? That is numerator by denominator. Are you able to follow? Numerator by denominator. So in that case you had to subtract. So this is equation 1, this is denominator value. So you had to subtract. So let us subtract 0. Let us consider this value 0.3870 and this one 1.1001. Now subtract. So 0 minus 1, 9. That is 10 minus 1, 9. And you already taken 1 from this, so 6. So you can drop 6. And here again 8. 3 minus 1, 2. Now you got 0. So 0 minus 1, you can put 1 bar. Okay. And then now you have to take the antilog for this one. Antilog. How to check the antilog? You have to consider the mantissa only. So this portion is called mantissa and this is the characteristic. So this is the portion. So we can consider only this. So you got antilog table also. Here it is logarithm table. On the other side you have got antilog. Got it? Similar to logarithm. Now this is the inverse of logarithm. So antilog. You have got 2869. You have to consider only the decimal only. That is mantissa part. So 0.28 means 0.28. Where is 0.28? Let us consider 0.28. It's here. Okay. So 0.28 and now 69. Where is 6? 6 is here. 0.28. 6. You can use scale. Okay. So 1932. 1932 and the difference is 4 for 9. So 1932 plus 4, 1936. Are you able to follow? This is the main difference. So you have 1936. Now you have to take single digit. You can consider single digit. Okay, consider this a single digit. So you can call it 1.932. This is the value, and whatever the value here should be taken as 10th power. So 10 power minus 1. So this is the final logarithmic value, solved value. Now we cannot stop with that because we have got already, that is this one, 10 power minus 3 is there. So 10 power minus 3 means here you have 1.932. You can include this. Okay. So this is the answer, 1.932. You can include here 1.932 into 10 power minus 1. So this is already 10 power minus 3. So that is equal to 1.932 into 10 power minus, this is minus 1, this is minus 3. By applying a power m into a power n plus n. So minus 1 plus minus 3. So minus 4. This is the final answer. Okay, got it? Logarithmic rules. There are around 9 rules in these logarithmic functions. Let us discuss one by one. Log of m into n to the base b is equal to log m to the base b plus log n to the base b. This is called product rule. Since m and n involved in product, that is multiplication. Log m divided by n to the base b is equal to log m to the base b minus log n to the base b. This is called quotient rule. So when there is a multiplication, we add. When there is a division, we subtract. Log m power k to the base b. Here this power comes to the next one, that is in the coefficient. Log m power k to the base b means this k comes to the coefficient. So it is called k into log m to the base b. This is known as power rule. Next, let us consider log b, log 1 to the base b. It is always 0. Log b to the base b is equal to 1. Log m to the base e, it is called natural log. It is represented as log m, that is ln m. Log m to the base 10, this is generally represented as log m, which is nothing but log m to the base 10. Log b power k to the base b is equal to, this k comes to the coefficient, so k into log b to the base b. We already know log b to the base b is equal to 1. So k into 1 is equal to k. Then b power log k to the base b is equal to k, because the exponent and the logarithmic terms are, that is, they are the inversions. So it becomes k. We should note here, that is, m and n are positive real numbers, whereas the b indicates the base, which is always greater than 0. It is positive, and also it is not equal to 1. So these are the fundamental rules about logarithm. Exponent and logarithmic functions. Let us consider m cube as 5. This is the exponent form. The base is m here. This is called the base. And 3 is the exponent. 3 is the exponent. And the answer is 5. Here, this can be converted into, that is, this exponent form can be converted into log 5 to the base m. That is, this base in the exponent form is retained as the base in the logarithm. And the answer here is taken in this place. And the exponent 3 is the answer of the logarithmic function log 5 to the base m is equal to 3. So this is called logarithmic form. So you should be able to convert the exponent form into logarithmic form and vice versa. Let us consider another example. So here log 16 to the base 4 is equal to 2. This is the logarithmic form. Now we need to convert this into exponent form. So 4 is the base, you can write the base here, and here 2, that acts as the exponent form. So that is the power term. Now 4 squared is equal to 16. So you should be able to convert this exponent form again into logarithmic form. Let us consider this simple example. Log x is equal to, that is to the base 3 is equal to 7. So this can be converted into the exponent form and thereby we can find out the solution. Let us consider this log x to the base 3. So retain this base 3 here and 7 as such. So this 7 can be brought here. So 3 power 7 is equal to x. Now if 3 power 7 is equal to x, we can find out the value of 3 power 7. So you can split this into 3 cube and 3. Therefore 3 cubes are 27. So 27 into 27, that gives 729, again multiplied by 3. So the answer is 2187. Are you able to follow this? Right. Next one. Let us consider log 2 to the base 10. We know the value of log 2 to the base 10 is 0.3010. So log 2 to the base 10 means, let us have this base, and this is the base in exponent form, and 0.3010. Are able to follow? 3010. That should be taken here. Okay, therefore now let me explain once again. Log 2 to the base 10 is equal to 0.3010. Now this is the base 10 and put the term here 0.3010, that is equal to 10. So this is the exponent form. Now let me explain. We know already 10 squared is equal to 100. That is nothing but 10 into 10. Is it not? Then 10 power 1 is equal to 10. That we know. But 10 power 0 is equal to 1. Anything power 0 is equal to 1. Now let us further come down. 10 power 0.5, which is nothing but 10 power half. That is root 10. So in the previous cases, that is how many times the 10 should be multiplied so that we can get 100. It means 2 times you had to multiply, we can get 100. If you take 1 time 10, if you take 0 time 1, if you take 3 times 1000, if you take 4 times 10,000, likewise it goes. But here when it comes down, that is less than 0, instead of less than 0, that is when it is a fraction, okay, that is less than 1. So when it is less than 1, it becomes a 10 power 1 by 2. That is, let us have a scale like this. This is 0, this is 1, this is 2. So in this case, this is 10 power 0. That is equal to 1. So when it comes here, let me say that is exactly 1 by 2. It means a 10 power half. Okay. So if it is 10 power half, which is nothing but 0.5, that is 10 power 0.5, that can be taken as square root of 10. Right. Now you look at this. In this case, what can be taken as a root so that we can get the result as 10. For example, 10 cube 3 times, so that you are able to get 1000. 10 square, 10 into 10, 10, 10 power 0, 1, 10 power 0.5 means 10 power 1 by 2, which is nothing but root 10. But what about this 10 power 0.3333, 3 bar? So that is nothing but 10 power 1 by 3. It means cube root of 10. So you have to find out the number so that when it is multiplied 3 times, you can get 10. That is the meaning. For example, 10 power 10 raised to power 0.25 means 10 power 1 by 4, is it not? So fourth root of 10, what does it indicate? That is, it is the number which can be multiplied by 4 times, so that you can get 10. So this is the way you should be able to understand. Okay. Right. Now let us proceed. Let us consider 16 squared. We know very well 16 squared is equal to 16 into 16, that is 256. 16 cube means 16 into 16 into 16, it goes 16 power n. So 16 into 16 into 16, n times. Then 16 power n minus 1 means what? We can apply the formula here. That is 10 power, a power m divided by a power n is equal to a power m minus n. So we can indicate this one. Okay. So in that case, we can apply 16 power n minus 1 is nothing but, that is 16 power n divided by 16 power 1. So we have applied this quotient formula of radicals, and therefore when you got this number, which is nothing but 16 power n times divided by 16, and 16 power 0 is nothing but 1. 16 power half is nothing but square root of 16, that is nothing but 4 plus or minus 4. 16 power 1 by 3 is nothing but the cube root of 16. Okay, you can further factorize and get it. And similarly 16 power 0.5 means 16 power 1 by 2, that is nothing but square root 2. Okay. Let us consider this problem, that is evaluation of log 64 to the base 2. So log 64 to the base 2 can be taken as x, and 2 power x, this is the base. So this is the base in the exponent form, and x can be written here. So 2 power x is equal to 64. Therefore 2 power x is equal to, this 64 can be factorized so that you are able to get 2 power 6 times. So 2 power x is equal to 6. Now the base is equal, therefore the exponent forms should be equal, so x is equal to 6. Got it? Evaluate log of 5 to the base 125. When you write the logarithm, you must always leave a space like this and put the base here. So this is 125. Okay, and you should also understand that when I put log simply as such, for example log 3, it is understood that log 3 to the base 10. When I write natural log, I can put simply log 4. It means log 4 to the base e. Okay, to the base e. Right. Now here evaluate this much, that is log 5 to the base 125. So put x, and 125 is the base, you can write here, and power x. Okay, this x can be brought here. Now that is equal to 5, and 125 is the bigger number, so that can be factorized so that you are able to get 5 cube of x, 5 cube power x. You can apply this formula, that is power rule of radical, a power m whole power n is equal to a power m into n. So 5 power 3 of 5x power x is equal to 5 power 3 into x, that is 3x, that is equal to 5. You can put 5 power 1. Therefore 3x, you can compare the base. Okay, so 3x is equal to 1 and x is equal to 1 by 3. So we have evaluated the x. Next, evaluate log 1 by 27 to the base 3. So log 1 by 27 to the base 3, that is equal to x. So 3 power x is equal to 1 by 27. So 27 is the bigger number, that can be factorized, so that becomes 3 cube. So you can put 1 by 27 means 1 by 3 cube, which is nothing but you can apply the inverse operations. Okay, 1 by a power m. Okay, that is equal to a power minus m. So in this case 1 by 3 cube is equal to 3 power minus 3. So 3 power x is equal to 3 power minus 3 means x is equal to minus 3. Right. Now let us move to the next sum. In fact, Adrian Willac, he is a Dutch mathematician. He has developed wonderful table of, he has published this table with 1 to almost 100,000 numbers as log table. Now log 32 is equal to log 2 power 5. So log 2 power 5 means now this 5 can be brought power by adopting power rule. Log m power n is equal to n into log power m. This n becomes the coefficient of logarithmic term. So 5 into log 2 and 5 into 0.3010, that is log 32. So with the known value we can find out the log table, okay, find out the unknown value of logarithmic values, and in fact a table has been already arranged, organized by Dutch mathematician. So you can also do that. In your Klux table almost up to 100 or 99 you would have got those values, right? Log 3x plus 5 to the base 2. So this is another question. So here that is equal to 4. We need to find out x. So we can put 2 power 4. So this is the base, power 4. So 2 power 4. You can bring this to this RHS. So 2 power 4 is equal to 3x plus 5. So 16. 2 power 4 is nothing but 2 into 2 into 2 into 4 times. So 16 is equal to 3x plus 5, and 3x is equal to 16 minus 5, that is 11. So x is equal to 11 by 3. And similarly you can proceed with the next sum, that is log x is equal to 0, minus 2. So log x, in fact what is x, and using 10 as the base, so you can put x to the base 10. So 10 power minus 2 is equal to x. So this 10 power minus 2 can be written as 1 by 10 square, that is equal to x, which is nothing but 1 by 100. Okay, I hope you should have enjoyed this video lecture, and by practicing more number of problems you can get expertised in the logarithmic functions. Thank you very much. Let us consider 10 power 2 is equal to 100. That you know very well, is it not? 10 power 2 is equal to 100. 10 power 3 is equal to what? 1000. Now let us take logarithm. Logarithm of 100 is nothing but log 10 squared. Am I right? As I already mentioned, when it is a base log to the base 10, so it can be interpreted like this: log 100 to the base 10. This means log 10 squared to the base 10. Am I right? Therefore, we can apply the power rule. So 2 into log 10 to the base 10. As I already given, log any number to the base the same number, that becomes 1. In that case 2 into 1, that is equal to 2. Is it clear now? And that is why we put log 100 is equal to 2. Got it? Log 1000 means we take that power term, which is nothing but 3. Right? Now let me consider log 2. We give the value 0.3010. What do you understand from this? When I write log 10, 100, that is, let me put to the base 10, to the base 10. So we can write the exponent form as 10 squared is equal to 100. Do you agree with me? Okay, so let me write that one also. Take down 10 squared. Let me write once again. Log 100 to the base 10, that is equal to 2. Got it? So it means we can convert this into exponent form. 10 squared is equal to 100. What does it indicate? For example, let me put log A to the base b is equal to c. It means, that is, I can put the base b here and power c is equal to a. Do you understand this? Okay, note down this formula. So this is the exponent form and this is the logarithmic form. Do you understand? So an exponent form can be converted into a logarithmic form. Got this? So let me try to explain log 2 to the base 10, that is equal to 0.3010. What do you understand from this? That is nothing but 10 power 0.3010 is equal to 2. Are you able to follow this? Got it? This is the meaning. Okay? So from this, in fact, we can calculate the 10 power, put x, and there is some number. You can calculate that number. And that is why, suppose, let me put 10 power x is equal to, what is that? Let me say 10 power x is equal to 1000. Right? 10 power x is equal to 1000. We have to find out x. How to find out? We can use logarithm. Are you able to follow? Otherwise, you can do by the conventional method, like take this also in terms of 10. So 1000 is nothing but 10 into 10 into 10. That is equal to 10 cube. That is 10 power x. Both the bases are 10, therefore x is equal to 3. This is one way of writing the answer. Excuse me. Got it? Now let me apply the logarithm for this. Shall we? Right. So let us consider ten power x is equal to 1000. Find out the value of x. What we are supposed to do? Take logarithm on both sides. Okay, so this is the way you have to do. So log 10 power x is equal to 1000. Got it? And you can apply the power rule. What do you mean by power rule? Log power rule. Log a power b is equal to b into log a. That is, this power b is written as coefficient of logarithmic a, right? So similarly, I can bring this x here. So x, and you know very well, when I put log 10, which is nothing but log 10 to the base 10, right? So x into log, what is that? 10 to the base 10 is equal to how much? And I have to consider the log of 1000 also, because introducing logarithm on both sides. So log 1000. Okay, so log 1000 is nothing but, if you have got 3 digit, you can check the value also. The value is 3.000. You can check with the table value. Now log 10 to the base 10 is nothing but 1. X into 1 is equal to 3.0. Therefore x value is 3. Okay, and that is why 10x. So we have got the same value, 3. Okay, now let me explain how we are able to get the value of log 2. Okay, right. Now listen. Similarly, let us consider log 2 to the base 10 is equal to 0.2 0.3010. Okay. So what does it indicate? This is nothing but 10 power 0.3010 is equal to 2. Got it? So now let me say I do not know this value. Put x. So 10 power x is equal to, I got the value 2. Now what am I supposed to do? Taking log on both sides. So log 10 power x is equal to log 2. Got it? So I can put x log and then 10. Of course this is base 10. As I already explained, log a to the base a is equal to 1. So that is equal to log 2 is nothing but 0.3010. Now x into 1 is equal to 0.3010. Therefore x is equal to 0.3010. Are you able to follow this? Okay, take down. So I hope now you should be able to understand the inner meaning of this logarithm. It talks about the exponential term. Okay. So we can convert the exponential term into logarithmic term and logarithmic term into exponential term. You should be able to exchange it. Okay. Now let me write some numbers. Try to convert it. We'll discuss tomorrow. But please go through all these things. Let us discuss how to solve squares, square roots based on logarithm. Let us consider a very simple problem. Square root of 400. So we need to solve this simple sum. We know very well it is 20, but let us go by the logarithmic method. You know very well square root of 400 is nothing but 400 power 1 by 2. We know the formula, that is power rule in logarithm. That is log of a power m is equal to m into log a. So this is known as the power rule. Take down. Power rule of logarithm. We can adopt this. So in that case, log 400 power 1 by 2 is nothing but 1 by 2 log of 400. And the log of 400. Okay. So 1 by 2. What is log of 400? You can check. So for 400, 3 digits are there. You can put 2 point. So 2 point. And you have to check 40 and 0. Check. It should be 60, 20. Now you can strike out. And this is 1 time. And this is 3010 times. Now you get 1.3010. You have to check antilog for this. So antilog and check antilog, it will be 2000, 200. And what you are supposed to do, you have to take 2 point and take this as 10 power 1, which is nothing but 20. Now we got the result. So the answer is 20. Got it? Okay. So I will give you a very simple sum. Find out the square root of 9 into 10 power 4. square root of 9 into 10 power 4. So we can take this as 9 into 10 power 4 whole power 1 by 2, right? And that is equal to 9 into 9 power half into 10 squared, is it not? Because you have to bring inside. So 9 power half into 10 power 4 power 1 by 2. So that becomes 2. So 10 squared. We know very well 9 power root 2, that is 9 power 1 by root 1 by 2 is nothing but square root of 9, that is 3. But let us go by logarithm. Okay, let us find out log of 9 power 1 by 2 into 10 squared. So let us eliminate this 10 squared, so we can retain this, and finally we can add. So find out 9 power 1 by 2 only. So 9 power 1 by 2 is nothing but 1 by 2 into log of 9. So that is equal to 1 by 2 into, find out the logarithm, get me the logarithm of 9. 9 means you have to check in 90, and log 9, it is single digit, so you can put 0 point. So 0.9, check in logarithm. 9542. Now you have to divide by this, so you are able to get 4 2s are 8, balance 1 15, 7 2s are 14, balance 1, 7 2s are 14, and 1 2s are 2. Now you had to check this for antilog. So find out antilog for this. Antilog .47, you have to check in 7 and add the mean difference 1. 3000. So you have this 3000, and what you are supposed to do, take single digit and into 10 power this 0. 10 power 0 is nothing but 1, therefore 3 is the answer. Now you have got already 10 squared, so you have to include that. Therefore 9 into 10 power 4 square root 2 is equal to 3 into 10 power 2. So this is the final answer. Got it? Okay. Now let me take some squares. Take down. Find out the value of 25 squared by logarithm. 25 square. So we had to find out by logarithmic method. So take log of 25 squared. Apply the power rule. So 2 into log of 25. Now find out the logarithmic value of log 25. Logarithmic value of 25. Get me that? So get me the book. So log, so you can take log 25, 0. So here it is 3979. Is it no? Log 25, find out the value here in 0. So 3979. Okay. So 39, and this is 2 digits. So you have to put 1 digit. 3979. Multiply it by 2. So 2 9s are 18, balance 1. 2 7s are 18 plus 1 19, balance 1. 18 plus 1 19, balance 1. 26 27. So 2.7998, and check the antilog for this. What is antilog? 0.7998. So you have to check 0.7. So you got 0.7, and check in 9 and 8. 0.79 is here. 6295. So 6295 plus, check it in 8, main difference. So 79, main difference is for 8. 79 main difference for 8. 8 is 11, is it not? So you can add 11. Now you have 6, 10, and what about this? 3, then 6. Okay, you please check once again for 25. Logarithm 25. What is the value? 25, 3979. Our value is correct. And check whether it is multiplied properly. 2 into 1, 2. And the last one is 58, is it not? Okay. 58. Now check. Recheck. 7958. So 7958 antilog. 7958. How much? 795. 6237. 6237, and check in plus 11. Are you sure? 7958. 7958. 8 means 11. So now you have 8, 4, 2, 6. So our value is 6.248 into 10 power 2, which is nothing but 624.8, roughly 625. So 25 squared is 625. Got it? Okay. Now find out. Let us take some complicated sums in squares and square roots. You can apply for cube roots also. Now let me take some complicated value. Let us consider 4, 7, 8, 9 cube root. Okay. So let us find out the cube root of 4, 7, 9, 8, 9. Find out how to proceed. That is 4, 7, 8, 9. 4, 7, 8, 9 power 1 by 3 cube root. Therefore log of 4, 7, 8, 9 power 1 by 3. So apply power rule. 1 by 3 into 4, 7, 8, 9. Okay. So you have to find out log here. Log. So 1 by 3, get me the value of log 4, 7, 8, 9. That is 3 point, because it has got 4 digits. 3 point, check 47 and 8, 9. 47, 8, 9. So you got the logarithm here. 47, 8, 9. So 47, 8, 47, 8, 6, 7, 9, 4. Yes, sir. So 6, 7, 9, 4 and 9 in 47. So 47, 9 means 8. So add 8 to this. 12, balance 1, 10, 8, 6. So you have 6802. 3.6802. So divide this by 3. 1 time, 2 times, this is 2 times, and balance 2, 6 times, and 4 times. Now take antilog for this. Okay. So 2264. How to check? Go to, you have to be very careful because on the subsequent tables you can find natural, science, etc. other tables. Take care. Now, so this is 2264. So 22, where is 22? 22 6. 22 6, how much? 1683 and 4 2. So 1685. 1685. Now you have to put 1 point into 10 power 4, 1. So that is 16.85. So this is the answer. Got it? Okay. Welcome to Saitechinfo channel, my dear UPSC and TNPSC aspirants. இன்னைக்கு நாம் மிக முக்கியமாக லாகரிதம் பேஸ்டு ப்ராப்ளத்தெல்லாம் ஹேண்டில் பண்ண போகிறேன். இந்த ப்ராப்ளம் யூபிஎஸ்சிலையும் சரி டிஎன்பிஎஸ்சிலையும் எந்த ப்ரிலிமினரி எக்ஸாமினேஷன், அதாவது இந்த ஃபில்டரிங் எக்ஸாமினேஷன் சொல்கிறோம்ல, ஃபஸ்ட் லெவலில் நடக்கக்கூடிய எக்ஸாமினேஷன்ஸ், பர்டிகுலராக எம்சிக்யூ டைப்பில் இருக்கக்கூடிய கொஷின்ஸு. ஸோ இதெல்லாம் இந்த நியூமரிக்கல் ஆப்டிடியூட் அப்படின்னு சொல்லுவாங்க இல்லையா. ஸோ இதில் இந்த ஆப்டிடியூட் டெஸ்ட்டில் இது வந்து ரொம்ப யூஸ்ஃபுல்லாக இருக்கும். இது மாதிரி இது நாட் ஒன்லி ஃபார் யூபிஎஸ்சி டிஎன்பிஎஸ்சி, எந்த காம்படிட்டிவ் எக்ஸாமினேஷன்லேயும் இந்த லாகரிதம்ங்கிறது ரொம்ப இம்பார்ட்டன்ட் கான்செப்ட். அந்த நியூமரிக்கலில் இது கண்டிப்பாக கேட்கறதுக்கு சான்ஸ் இருக்குது. ஸோ அதை பற்றி நம்ம டீட்டெயிலாக டிஸ்கஸ் பண்ணலாம். இப்போது a power b is equal to c, இதை தான் நம்ம எக்ஸ்பொனென்ஷியல் ஃபார்ம் அப்படின்னு சொல்லுவோம். அண்ட் இந்த எக்ஸ்பொனென்ஷியல் ஃபார்ம் ஃபார் இன்ஸ்டன்ஸ் நமக்கு ஏற்கனவே தெரியும் பாப்புலராக 2 cube is equal to 8, which is nothing but 2 into 2 into 2, that is 8 அப்படின்னு தெரியும். அப்போது இதை, அதாவது இந்த a power b is equal to c அப்படிங்கிற டேர்மை இது எக்ஸ்பொனென்ஷியல் டேர்ம் அப்படின்னு சொல்கிறோம். இதை வந்து அதாவது பவரில் போட்டு சொல்கிறது. இதை லாகரிதமிக்காக நம்ம ரெப்ரசன்ட் பண்ணலாம். அப்படி லாகரிதமிக்காக ரெப்ரசன்ட் பண்ணுறப்ப என்ன பண்ணுறோம்? log of c, அதாவது RHSல உள்ள வேல்யூ log of c, இந்த பவர் டேர்ம் வந்து கீழே வந்துடும். தட் இஸ் கால்ட் பேஸ் அப்படின்னு அர்த்தம். டு த பேஸ் a. ஸோ சொல்கிறப்ப எப்படி சொல்லணும்? log c to the base b, that is equal to a அப்படின்னு சொல்லணும். ஸோ திஸ் இஸ் கால்ட் logarithmic. ஓகே, logarithmic ஃபார்ம் அப்படின்னு பேர். சரியா? இப்போ இந்த எக்ஸாம்பிள் எடுத்துப்போம். 2 power 3 is equal to 8. அப்போது இது எப்படி வரும்? log 8, அதாவது இந்த RHS அந்த வேல்யூ இங்கே வந்துடும். அண்ட் டு த பேஸ் 2, அதாவது இந்த பேஸ் இங்கே உள்ளது பேஸில் வந்துடும். தட் இஸ் ஈக்குவல் டு பவர் டேர்ம், தட் இஸ் ஈக்குவல் டு 3 அப்படின்னு சொல்கிறது. புரியுதுங்களா? இப்போ இதில் சர்டன் ரூல்ஸ் இருக்குது. அதில் மெயினாக 3 இம்பார்ட்டன்ட் ரூல் நீங்கள் நல்லா தெரிஞ்சுக்கணும். ஃபார் இன்ஸ்டன்ஸ் log a into b to the base, இல்லாட்டா m என்னன்னு வச்சுக்கோங்க, அது பெட்டராக இருக்கும். m into n to the base a அப்படின்னு வச்சுக்கோங்க. அப்போது இது வந்து என்னது? இந்த நம்பர் வந்து ப்ராடக்டில் இன்வால்வ் ஆகிருக்கு. ஸோ திஸ் இஸ் கால்ட் ப்ராடக்ட் ரூல். இந்த ப்ராடக்ட் ரூல், அதாவது 2 எலிமெண்ட் ப்ராடக்டாக வந்தால் லாகரிதமிக்கில் எப்படி வரும்னா ஆட் ஆகும். ஸோ அப்போ log m to the base a plus log n to the base a. சரியா? அடுத்தது கோஷன்ட் ரூல். ஸோ இது பேர் என்ன? ப்ராடக்ட் ரூல். நெக்ஸ்ட்டு கோஷன்ட் ரூல். எப்படி மல்டிப்ளை பண்ணணுமோ அதே மாதிரி டிவைட் பண்ண போகிறோம். ஸோ கோஷன்ட் ரூல். இது பிரகாரம் or log m divided by n to the base a is equal to log m minus log n அப்படின்னு வரும். சரியா? ரைட். அதே மாதிரி ப்ராடக்ட் ரூல். ஸோ இதில் நல்லா கவனிங்க. இதில் ப்ராடக்ட் ரூல் என்ன பார்த்தோம்? m இன்ட்டு என்னன்னா m log of m plus log of n அப்படின்னு வரும். கோஷன்ட்டில் log of m minus log of n அப்படின்னு வரும். அடுத்தது இங்கே வருவோம். இப்போது log of, அதாவது this is called power rule. இந்த 3 ரூலு நீங்கள் இம்பார்ட்டண்ட்டாக தெரிஞ்சுக்கணும். அதை தவிர நிறைய ரூல் இருக்குது, பட் இதுதான் பேசிக்கான 3 ரூல். இதில் பவர் ரூல் அப்படிங்கிறது log, let me say m power n to the base a. அப்போ இந்த பவர் டேர்ம் என்ன ஆகிடும்? ஃப்ரண்ட்டில் வந்துடும், கோஎஃபிஷியண்ட்டாக வந்துடும். ஸோ n இன்ட்டு log of m to the base a. இது நீங்கள் கண்டிப்பாக தெரிஞ்சுக்கணும். ஸோ என்னென்ன சொன்னேன்? லாகில் ஜென்ரலாக இந்த எக்ஸ்பொனென்ஷியல் ஃபார்மை லாகரிதமிக் ஃபார்மை எப்படி மாற்றுறதுன்னு சொல்லியிருக்கேன். அதுக்கான எக்ஸாம்பிள் கொடுத்துருக்கேன். அதுக்கடுத்தது இங்கே அதோட ரூல்ஸ் மொத்தம் 3 ரூல்ஸ் சொல்லியிருக்கோம். ப்ராடக்ட் ரூல் அப்படின்னா m இன்ட்டு என்னன்னா log m ப்ளஸ் log n வரணும். டிவிஷன் அப்படின்னா சப்ட்ராக்ஷன். அப்போ இந்த இடத்துட்ட பவர் ரூல் அப்படிங்கிறப்போ இந்த பவர் n ஃப்ரண்ட்டில் வரணும். இதை நீங்கள் நல்லா தெரிஞ்சுக்கணும். இதை பேஸ் பண்ணி சில எக்ஸாம்பிள்ஸ் பார்ப்போம். சரியா? நோட் பண்ணிங்க. நீங்கள் வீடியோவை அப்பப்போ பாஸ் பண்ணி நோட் பண்ணிக்கோங்க. தட் இஸ் குட் ஃபார் யூ. இப்போ இந்த ரூலை பேஸ் பண்ணி சில சின்ன சின்ன சம்ஸ் பார்க்கலாம். இப்போ log 5 into 2 இதோட வேல்யூ என்ன? இது எப்படி இருக்குது? ப்ராடக்ட் மல்டிப்ளிகேஷனாக இருக்குது. அப்போ ப்ராடக்ட் ரூல் அடாப்ட் பண்ணலாம். அப்போ என்ன வரும்? log 5 ப்ளஸ் log 2. அவ்வளோதான். சரியா? அடுத்தது log, let me write, say that is 11 divided by 2 அப்படின்னு வந்தால் இப்படி வரும். log quotient rule என்ன டிவிஷனில் இருக்குது. ஸோ log 11 minus log 2. ஓகே. அதே மாதிரி log, இந்த ரூல் பேர் என்ன? quotient rule. log, for instance, let me say 8 divided by 2 power 3 அப்படி வச்சுப்போம். ஸோ அப்போ we can apply the power rule. ஸோ இந்த 3 இங்கே ஃப்ரண்ட்டில் வந்துடும். 3 log 2. தட்ஸ் ஆல். இதில் நீங்கள் ஒரு விஷயம் கவனிச்சு பார்த்தீங்கன்னா, இந்த இடத்துல நான் பேஸுன்னு அந்த ஏ கொண்டு வந்திருப்பேன். ஆனால் இங்கே எதுவுமே போடல. புரியுதா? அது ஏன் அப்படிங்கிறத இப்போ நான் எக்ஸ்பிளைன் பண்ணுறேன். ப்ளீஸ் நோட் ஆன் திஸ். இந்த பேஸ் அப்படின்னு பார்க்குறப்போ log anything to the base e, இது பேர் என்னென்னா இந்த e அப்படின்னு போடுறோம்ல, இது எப்படி சொல்லணும்னா நேச்சுரல் லாக் அப்படின்னு சொல்லணும். திஸ் கேன் ஆல்சோ பி ரெப்ரசன்டட் அஸ் நேச்சுரல் லாக் ஏ. புரியுதா? ஸோ அப்போது இந்த இடத்துட்ட இ அப்படின்ற எக்ஸ்பொனென்ஷியலாக இ அப்படின்னு வந்ததுன்னா தென் இட் ஷுட் பி கால்டு நேச்சுரல் லாக் ஏ. அதே மாதிரி யூஸ்வலாக லாக் ஏ டு த பேஸ் 10 அப்படின்னா டு த பேஸ் 10 அப்படின்னு சொல்லணும். இதை நிறைய பேர் லாக் 10 அப்படின்னு ஸ்ட்ரைட்டாக சொல்லுவாங்க. லாக் ஏன்னே சொல்லிடுவாங்க. ஸோ இட் இஸ் அண்டர்ஸ்டுட் லாக் டு த பேஸ் 10. சரியா? ரைட். இப்போது சார் இது ஈயும் 10 அது மட்டும்தான் வருமா? அப்படி கிடையாது. என்ன பேஸ் வேணாலும் வரலாம். பட் அதை ஸ்பெசிஃபிக்காக நம்ம இண்டிகேட் பண்ணணும். ஸோ நம்ம ஈஸிக்காக லாக் ஏன்னு எடுத்துகிட்டு போனோம்னாக்கா இட் இஸ் அண்டர்ஸ்டுட் தட் டு த பேஸ் 10 அதை மென்ஷன் பண்ணியிருக்கணும். டு த பேஸ் 10 இப்படி போட்டாக்கா நேச்சுரல் லாக், அப்போ லாக் டு த பேஸ் இ அப்படின்னு அர்த்தம். ஸோ இந்த கிளாரிட்டி உங்களுக்கு முதல்ல வேணும். புரியுதா? ப்ளீஸ் நோட் ஆஃப். இப்போ logarithm of சில எக்ஸாம்பிள்ஸ் பார்ப்போம். log 10 or 100 அப்படி எடுத்துப்போம். log 100 அப்படின்னா அதோட வேல்யூ என்ன? that is equal to 2. சார் இது எப்படி உங்களுக்கு தெரியும்? I will tell you. இது எப்படி பண்ணலாம்னா log இந்த 100 10 squared போடலாமா? So log 10 squared. So that is equal to, now we can apply the power rule, is it not? So 2 log 10. சரியா? And log 10 ஓட வேல்யூ அது தெரிஞ்சுக்கணும் 1. So அந்த பேசிஸில் that is equal to 2 into log 10 வேல்யூ தெரியும், that is 1. Therefore 2 into 1 2. அப்போ log 10 squared அப்படிங்கிறது என்னது? It is 2. இதை நான் ஃபர்தராக பில்டப் பண்ணுறேன். log 10 squared to the base, இங்கே என்னவா இருக்கும்? இது வந்து to the base 10 அப்படின்னு எடுத்துக்கிறேன். ஸோ log 10 to the base 10. ஸோ log 10 squared to the base 10. சரியா? ஸோ that is equal to, இந்த பவர் ரூலில் இங்கே கொண்டு வந்துட்டோம். ஸோ log 10 to the base 10. இப்போ இங்கே ஒரு முக்கியமான ரூல் ஒன்று இன்ட்ரோடியூஸ் பண்ணுறேன். அதாவது log of an element to the base of the same element is always 1. Please note down. அதாவது log of a to the base a is equal to 1. இது நீங்கள் முக்கியமாக தெரிஞ்சிருக்கணும். சரியா? ஸோ அந்த பேசிஸில் log 10 to the base 10 அப்படின்னா அப்போ அது 1. அப்போ 2 into 1 2 அப்படின்னு வந்துடும். புரியுதா? இதை இன்னும் கொஞ்சம் ஃபர்தராக மாடிஃபை பண்ணுறேன். ப்ளீஸ் கோ த்ரூ இட். இப்போ இந்த ஃபார்மேட் எடுத்துப்போம். அதாவது log 100 இது எடுப்போம். log 100 to the base 10 is equal to 2 அப்படின்ற வேல்யூ. இது என்ன? இது that is logarithmic term. நம்ம ஃபர்ஸ்ட் பார்த்தோம் இல்லையா? logarithmic term. ஃபர்ஸ்ட் என்ன பார்த்தோம்? log a to the base b is equal to c ன்னு பார்த்தோம்ல. ஸோ அந்த logarithmic term, logarithmic form, இதை வந்து நாம் எக்ஸ்பொனென்ஷியல் ஃபார்மாக மாற்றணும். எப்படி மாற்ற போகிறோம்? இதில் 10, இந்த 10 இங்கே இருக்கும், அடுத்தது இந்த 100 அந்த பக்கம் போயிடும். சரியா? அப்புறம் இந்த 2 பவரில் வந்துடும். இப்போ 10 squared is equal to 100 தானே? இதுதான் என்னது? எக்ஸ்பொனென்ஷியல் ஃபார்ம். புரியுதப்போ? ஓகேவா? ப்ளீஸ் நோட் டவுன். Now let us proceed. Let me introduce another value. Log 2 to the base 10 is equal to, இதோட வேல்யூ என்னன்னா 0.3010. Please note down. இது logarithmic table னு இருக்கு. அந்த டேபிளில் பார்த்தீங்கன்னா தெரியும். I will introduce this. So log 2 to the base 10 is equal to how much? 0.3010. அந்த பேசிஸில் இப்போ இதோட எக்ஸ்பொனென்ஷியல் ஃபார்ம் எழுதி பார்ப்போமா? அப்போ என்ன பண்ணுறோம்? 10. அடுத்தது நான் என்ன சொல்லியிருக்கேன்? இந்த வேல்யூ அதுதான் பவர் டேர்மாக வரப்போகுது. இங்கே வந்த மாதிரி. ஸோ 10 10 2 அது ஸ்கொயர்டாக வருது, பவரில் வருது. அதே மாதிரி இங்கே 0.3010 அப்படின்னு போட்டிங்கன்னா that gives you value என்னது? இந்த வேல்யூ வரும் இல்லையா? that is equal to 2. கரெக்டா? ஸோ அப்போ 10 பவர் 0.3010 அப்படிங்கிறதா அதனுடைய வேல்யூ என்னது? 2. ஓகேவா? ஸோ இதை தான் லாகரிதமிக்காக எழுதுகிறப்போ இப்படி ஆகுது. Are you able to follow this? Right. இப்போ from this it's clear that இப்போ நான் இன்னொரு வேல்யூ எழுதுகிறேன் log. இப்போ பேசிக்காக 2 அப்படின்றது வேல்யூ தெரியும். அதை பேஸ் பண்ணி how we can build up log, let me say 4 to the base 10. ஸோ இப்போ log 4 ஓட வேல்யூ என்னவா இருக்கலாம்? இது எப்படி போடலாம்? log 2 square to the base 10 ன்னு போடலாமா? அப்போ we can apply power rule, is it not? So that is equal to 2 into log 2 to the base 10. Done. So 2 into log 2 ஓட வேல்யூ எவ்வளோ? 0.3010. அதை அப்படியே போட்டு 3010. Now you can multiply. So 2 into 3010 is 6020. 0.6020. இதுதான் log 4 ஓட வேல்யூ. அப்போ டேபிளை ரெஃபர் பண்ணாமலே we can obtain the value of log 4. Do you understand? Right. So இதை ப்ராடக்ட் ரூலாக எப்படி பண்ணலாம்? இப்போ நான் பவர் ரூல் அடாப்ட் பண்ணியிருக்கேன். இதை பேஸ் பண்ணி ப்ராடக்ட் ரூலில் எப்படி இதை கொண்டு வரலாம்? Let me have the same sum log 4 to the base 10. இது என்ன பண்ணலாம்? இந்த 2 into 2 அப்படின்னு போடலாமா? ஸோ log 2 into 2 to the base 10. அப்போ இந்த இடத்துல ப்ராடக்ட் ரூல் அடாப்ட் பண்ணலாம், அதாவது ஆட் பண்ணலாம். therefore log 2 plus log 2 to the base 10. log 2 to the base 10 value தெரியும், 0.3010 plus 0.3010. therefore 0.6020. this is log 4. Okay, right. Now I will give you a small sum. Try to answer this. What is the value of log 8? Can anyone do it? Try. Log 8 can be written as 2 cube, is it not? 2 into 2 into 2 to the base 10. Therefore, according to the power rule, you can bring 3 to the coefficient. So 3 into log 2 to the base 10. Therefore 3 into 0.3010. So what is the value of that is log 8? That is 3039. So 0.9030. This is log 8. Are you able to follow? Right. Now let me introduce log 3 value. Log 3 is roughly 0.4771. Log 3 value is to the base 10, 0.4771. Please note down. So at least you should try to remember 235. That's enough. Now logarithm of 3, that is 0.4771. Now let us work out based on log 2 and log 3. Log 2 value we know, that is 0.3010. Let me have log 6. What could be the value of log 6 base 10? That is equal to log 2 into 3 to the base 10. So you can apply the product rule. So log 2 to the base 10 plus log 3 to the base 10. So that is equal to, what is log 2? 0.3010 plus log 3 0.4771. So that is equal to 1 plus 7 8, 7, and this is 7. So 0.7781. This is the value of log 6. So likewise you can obtain the value of 6, logarithm of 6. Got it? Right. Now let me take up 5. Logarithmic value of 5 to the base 10 is equal to 0.6990 roughly. Now we will work out the value of log 15 to the base 10. How can you do this? That is, log 15 can be split into 3 into 5, is it not? To the base 10. Therefore, you can apply the product rule. So log 3 plus log 5. You know the value of log 3, what is that? 0.4771 plus log 5 is 0.6990. So you can work out as 1, 9 plus 7, 16, balance 1, 10, 17, balance 1, 7 plus 4, 11. Okay. So 1.1761 is the value of log 15, right? So try to work out various values based on 2, 3, 5, okay? Right. Thank you for watching this video. We will continue with some advanced problems. Welcome to Saitechinfo channel, my dear UPSC and TNPSC aspirants. In the previous session, I was discussing about the basic rules basic rules of logarithms like product rule, quotient rule, followed by that power rule. So these 3 rules are very important, and we also discuss about the exponential form and logarithmic form. So you should be able to convert these 2 forms, that is from exponential to logarithm, logarithm to exponential. Now in continuation of that lecture, let me explain one important problem that has been asked recently in the CSAT examination of UPSC. Now this is the problem given. Log P divided by Z y minus Z is equal to log Q divided by Z minus X. That is equal to log R divided by X minus Y. Overall, it is equal to 10. Now listen, this is the first term, okay? This is the second term. This is the third term, and all of them are equal to this fourth term, that is 10, okay? Now the given is X is not equal to Y is not equal to Z. So X is not equal to Y, Y is not equal to Z. Now what is asked? PQR is asked, okay, right? And they would have given as 4 options. You have to select the correct answer. Now log P. So here we can apply the product rule. So the concept is, take down the concept, logarithmic product rule. This is the concept. Now let us apply the log P. Let us take the first term, log P divided by Y minus Z is equal to, let us compare with the fourth term, that is 10. And this can be rewritten as log P is equal to 10 into Y minus Z. So let us put this as equation 1. So when you multiply these 2 terms, you have to be very careful about the parentheses, the brackets. Then let us take the second term, that is log Q divided by Z minus X is equal to, compare with the fourth term, that is 10. And this can be rearranged as log Q is equal to 10 into Z minus X. Let us take this as equation 2. Then third term, that is log R divided by X minus Y, that is equal to 10. And this can be rearranged as log R, that is equal to 10 into x minus y. So this is the third equation. Now what is asked here? PQR, and we know when we apply the product rule, okay, so we can get, actually this is the product P into Q into R. So log PQR is equal to log of P plus log of Q plus log of R, is it not? So by adding the three equations, particularly the LHS, respective LHS, we can get this term, and based on that we can obtain the value. Please note down here it is asked PQR, not log of PR. So we have to take the anti-log of PQR, okay, and otherwise we can just compare with the RHS and get the value also. Now listen, how can you get this log P plus log Q plus log R from these equations, is it not? So you can add these equation 1, okay. So RHS can be added. Let us add equation 1, 2 and 3. So take the respective RHS log P, so log P, and here log Q, then log R. Now you can take the RHS. So this is LHS, this is RHS. So that is equal to, and in fact 10 of y minus z plus, and here second equation 10 of z minus x. Third equation 10 of x minus y, right? Now this log plus log q plus log r is equal to log PQR according to our definition, okay, according to our definition, right? So we can convert this as log of PQR by applying the product rule. That is equal to, and here 10 is common, you can take outside the bracket, and the remaining term can be added. So y minus z plus z minus x plus x minus y. So when you add everything, y is cancelled, y plus y minus y, okay. So x minus y plus y minus y cancel, plus z minus z cancel, x cancel. So it becomes a 0. So 10 into 0 means 0. Therefore we are getting log of PQR is equal to 10 into 0, that is equal to 0. So log of PQR is equal to 0. You should note one more important thing. Log of 1 is 0, okay. So based on that you can replace the 0 by log 1. Therefore, you cannot immediately say log PQR is equal to 0, so PQR is equal to 0, not like that. And you should remember log of PQR is equal to 0 means it is not PQR is equal to 0 by log. It is not in multiplication. Actually, this is a function, okay. So, we had to find out either the anti-log, otherwise you can equate like this. So, log PQR is equal to, instead of 0, you can write log 1, because log 1 is equal to 0. Now you can compare PQR is equal to 1. So the correct answer is PQR is equal to 1. Okay, so this is the correct answer. Do you understand? Otherwise, you can put it as anti-log, but I will explain about anti-log in the next class. You have here log PQR is equal to, what is that? Log PQR is equal to 0, right? You can apply the that is exponential rule also here. So this is in the logarithmic form, and this is, if you want to take the inverse of log, you have to consider what? The antilog. So what is the inverse of antilog? I mean log, it is antilog. So you have to find out antilog of PQR. So you can take like this also. So the antilog of PQR means that is equal to what? Because you can remove this log, okay, and therefore you have to take the antilog. But we will explain in detail about this antilog, okay. So for this, it is the value is 1. So you can put PQR is equal to 1. But let us have some practice based on antilog also, so that it will be very comfortable for you to arrive at the answer in that method. So instead you can have the same logarithm on both sides and equate, so PQR is equal to 1. Now in my next session I will explain about antilog.